Yaskawa.
You're watching the PLCopen Basics video tutorial series. This video shows how to accomplish a simple 2-axis positioning sequence. Hi, I'm Matt Pelletier. Now that the servos are enabled, we can focus on PLCopen motion. The most basic moves are relative positioning and absolute positioning. We'll start simple and build it up to a more complex repeating move sequence involving timers and simple ladder logic. Let's keep with the program layout and the program map that I've established, and we'll have a new POU now for positioning. And what task do you think positioning should run in? We have fast, medium, and slow by default. To answer that question, keep in mind that the task cycle rate, the scan time of the task, does not affect motion resolution, but it does affect when that motion can start. Normally we put motion in the fast task so that it can be stopped and started by machine conditions, which might also be running in that fast task. Now in our case, the slow task would also be fine since the execution is going to be coming from this HMI running in the slow task. So it could go either way, but we'll put it in the fast task in this case, as that's usually where it will be. So here I am connected to the demo. So we'll make a new POU, a new program POU called positioning with the ladder language. And I said we'd run it in the fast task. So got our program instance, positioning, and let's open that one up. I got my edit wizard here with PLCopen Plus. Now the move profile that we'll just somewhat arbitrarily select will be a distance of -270 millimeters with a velocity of 180 and an acceleration here as listed 360,000. Remember, this is the screw axis. We're working in millimeters per second for velocity and second squared, and millimeters per second squared for accel and decel. That is the way PLCopen units work. It's the unit per second, and per second squared. And so we'll expect to see our motor do this, 270 degrees clockwise. So if you'd like to try this out, go ahead and pause the video, and I'll show you my solution right after that. So I'll put in an MC move relative on the screw axis. And for the execute input, we're using G start. And now we need to make some local variables for distance and tab down here to the var usage. Now, you could leave the initial value at 0 and just type in the 180 in debug mode, but let's give it that initial value, -270.0. This is an L real, so you've got to have the decimal point. And move on to velocity. Call a new variable velocity. It's a var with initial value 180.0 and enter. Now XL decel could also be variables, but I'm just going to use a literal value here. L real pound, and it recognizes that, grays out the rest of the fields. 360_000.0 underscore, again, is just there for formatting, so it's easier to read that that's 360,000. And one little trick here, you can control click to generate a copy. And we'll download that to the controller. Okay, we'll see if it works by opening the HMI POU. I don't have a lot of room here, so I'll use this. Go to debug mode. Go to toggle Boolean mode. My servos are on, so I just need to start. I'll zoom out a little bit just so I can see it. And here we go. I'll do it again. Off and on. Now it is going 270, although I'm not starting really at the expected up position, just because I happen to be somewhere else, and that's what relative positioning is. It's relative to where you are. I'll do one more time here. Off and on should be right about there. Yep. So that's an MC move relative. But before we do an absolute move after this, kind of makes sense to put the motor to what we might call absolute position 0. Now that is an arbitrary position, but I would like 0 to be with the motor arrow pointing straight up. So I think the easiest way to do that is to incrementally change the distance of this relative move. For example, I think if I go clockwise, maybe not 180, but maybe 190 degrees, I'll end up at 0. So I'll just change my distance to negative 190.0. See how close I get. Turn that switch off and on. All right, wasn't quite far enough. What do you think I have? Maybe 5 degrees more. So change my distance here to negative 5. Toggle that again. All right, it doesn't look perfect, but it looks pretty close. Negative 1.0. I think I need maybe a little bit more and could inch it along here. Until it looks perfect. All right, I think that looks pretty good. And now I'll get back to my program mode here. Off to the side, let's see where we're at with an MC read actual position for the screw axis. And you can just arbitrarily enable that to true. This is the way that PLCopen reads in actual position. And to set the position, we'll do MC set position, also for the screw axis. And we'll just execute this straight within the code here. Call it set 0, a local variable. And the position will be called 0 position. And I'll leave that at LReal 0.0. That only makes sense. This mode in the help shows that mode is 0 for absolute, which means that's the absolute position, or relative means that you'd add that position. As it says down here in the notes, if mode is false, the position input is treated as absolute, and the exit position is defined as such. If mode is true, then the value of the position input is added, the sum of which becomes a new commanded position without any motion occurring. So you can jump your position up with this set position without moving. That's not what I want to do. So we'll leave this in absolute mode 0 just by leaving it disconnected. Now I'll download changes and close that in debug mode. So now we see the feedback position after several of those moves. And when I set the 0 position, just double click on it and click overwrite, the position becomes 0. And I'll release that one. Now we have 0 with the motor at this mechanical position. Now let's continue with this move and make it into a move sequence. So what I would like us to do is, after this relative move of negative 270, can we do an absolute move back to 0? So the motor will basically move out and then move back immediately. So if you think you know what to do, go ahead and program this, and I'll give you my solution. Okay, let's add a move absolute, MC move absolute for the screw. And you can do it two ways. You can either take this line and connect it, which kind of makes you want to work horizontally. So since we have gravitated toward a vertical layout, what I usually do is don't use these lines. Instead, I'll just create a variable called done screw relative. And then with the control key, I can create a copy of that. And it just looks a little cleaner. And then this will be done screw absolute. Another trick here, I'm using the same velocity X, L, and D cell, so highlight those and Control click to place them on, and I've left with position, which I'd like to be 0. So download changes, and we'll start motion again. Set my distance back to 270. Off and on. So it goes out and back. Do that again here. Out and back. And you could look at the position during that time. Out and back. And here's my partial solution, just for the record. Now, the next thing I'd like to add is there's a way to get this type of sequence to repeat with timers in between. Well, let's take a T-on timer and put a delay time in between. By using this normally closed contact with the same variable as the last done of the sequence, we can cause this to trigger the move to happen again by putting it in series with the start. So again, if you think you know what to do, go ahead and try it, and I will show my answer. Okay, here's how I do it. I'm going to use the Shift key to take the done off. And right on the done, I know the name is called T-on. And it'll just nicely put it right on there for you. T-on. PT, that's the delay time. I'm going to call that delay. And we'll give it a T pound 500 ms, 500 milliseconds. And we can do the same thing for the move absolute, create it from scratch. Use Shift here to remove it. You could also copy and paste, but then you have to be careful how to do that properly. So I think it's easier just to create it T-on number 2. There's the done for the screw absolute. And delay. Now I did this out of order relative to the illustration, but I will delete here the G start and put a contact left, another contact left, and then the left power rail. Notice that kind of shifted everything over. So if that bothers you, you can zoom out, capture it, line it up. Control question mark gives you back to 100%. Normally closed. This is going to be done. Screw absolute. And this was the G start. Since we're starting to get a few variables here between local and global, I will remind you, if you haven't done it yet, under Extras, Options, Graphical Editor 2, there's the Show Borders option, which puts different color shading on the globals of green versus locals blue. Sometimes that helps. And let's download changes again. And you can see it's working already. Now in debug mode, can keep an eye on this feedback position. You can see it gets to 270 and 0. Saw 270 there. So here is your final programming challenge. We haven't done anything yet with the rotary motor on the right side of the demo. So let's have it so that we have the screw does a negative relative, and then the rotary does a negative relative, then the screw does an absolute back to 0, and then the rotary does a move back to 0. Look like this. I did it in PowerPoint. You do it in PLCopen. Here's the solution concept, and I'll show you how I went about doing that click by click. So I think it makes sense to put the blocks in the same order that they'll be executing, just to avoid confusion. We need to have the layout auto scroll speed to slow. That'll take care of that problem. So make room for another MC move relative. Not enough room. Okay, let's try again. All right, there it is. Build it again. This time it's the rotary axis. And we'll be executing with the done of the previous block. We'll use the same distance velocity, accel and decel, using the control key. We'll put a T on. Sometimes these T-ons mess up, but you can usually fix it. Move that one over a little bit. We got done rotary relative. And use the same delay. So let's follow that through. We've got G start. This is done screw absolute. This one's going to have to change too. We'll do that later. Done screw relative starts the rotary relative. Done rotary relative should start the move absolute. So we'll change that one. Here's done rotary relative. Screw absolute. And now I'm sure some of you did this with copy and paste. It seems like a lot of work to rebuild it. I usually don't do too much copy and paste unless it's a lot of code. But I'll show you how to do it the right way. We copy and paste. Now we can try to fix this up. We know that this is not the screw but the rotary. And we know that this is done screw absolute. Let's change that. Done screw absolute. And this will be done rotary absolute. But what often happens is when you think you're done, you try to download changes, get all these errors because you didn't copy and paste correctly. And what's happening, I know we went over this in IEC basics, but it bears repeating, is this MC move absolute 2 is not in the variable list. There's an MC move relative 1, move relative 2, move absolute 1, but there's no move absolute 2. When you paste a block, you have to confirm that and declare it. You double click on it and click OK. And doing that puts the instance in the variable list. So copy paste can work, but every block, including the T-on, must be confirmed so that it ends up in the list. Okay, add a couple more things here. This PT needs the delay. And done rotary absolute. This is another common mistake I see. Done rotary absolute should be what triggers this ladder. This up here should be done rotary absolute. Okay, so change that one out. And now it'll work. Download changes. Ooh, I got an error. Bool type time. Oh, it didn't put it in the right spot. I'll delete that. Delay. Try again. Still got an error. Still think it's there. Interesting. Try this again. Delete it. Check delay. Delay is time. Download changes. Okay. And you can see here it didn't even have to trigger anything. The left motor is moving, the right motor is moving. Naturally, if you have the MP2600 IEC, you only have the one motor, and the other motor is like a ghost motor, the virtual motor. will be going through the virtual motions of the positioning move, but you won't actually see anything happening on the demo. I'd like to make one final comment, which is notice the execution turns red here and follows this sequence. And so it's the fact that this execute input is turning on and the done output stays on, which is the whole reason that this sequence can repeat. So if you were to turn off the start, first of all, notice that it completes whatever move it's on. I'll do that again here. So we're doing the right motor and it stops, but it completes the move. And then if you turn that on again, it just starts over at the beginning. So this is not a pause resume button. It's basically cancels at the next block and then starts over. And of course, the secret to it all is this normally closed bit that very quickly turns off and on. You really can't see it here, but this is just one way. I'm sure there are more elegant ways to make a repeating sequence, but this is just a very quick and easy way to do it here in the training class. Now, as a final wrap-up, I'd like to show a way that you can save what you have here without changing the project name, which is important if you want to continue using download changes, that you don't keep changing the project name, but you may want to save a copy. Save a copy here, save project as, and then in your projects folder, you can just rename it, and I'll call it 06 MC Move. We're using the MC Moves. And that's the name of the video that we just got done with here. And choose zipped project file and zip it. Your name is retained of the working project file, but you have in Windows now a copy of it, and you can always unzip this and work with it again. So that's some basic positioning. This is our program, and I hope that that helps you. A lot of applications can be done with just simple move relatives and move absolutes.